Okay, Bismillahirrahmanirrahim. Let us do more example under the integral by simple U-substitution. So as of now, you can see that in order for us to integrate, we do need to know how to differentiate at the same time. Let's analyze back, okay, the formulas that we have had, okay, from the given list just now. Right, so in order to differentiate x, we get 1. In order to integrate 1 with respect to the x, we get back the x. Okay, another one. In order to differentiate x power r, the formula, the basic formula is r x power r minus 1. And if you are integrating this term, you'll get back the x power r. But yet, the basic formula to integrate x power r is x power r plus 1 over r plus 1. I'm showing it to you there so that you can know the difference between the formula to differentiate and the formula to integrate. Okay, so the derivative of the 1 on x, okay, is, let's say, x power negative 1, so we can use this formula. So it is negative x power negative 1 minus 1 negative 2. This is the answer for your differentiating of 1 on x. Whereas, compare when we are to integrate 1 on x, the formula is ln x. Okay, as we differentiate ln x, you will get back the 1 on x. There you can see the relationship between differentiating and integrating. Okay, integrating is actually the antiderivative of the function. Then let's analyze formula number 4. We need to get familiar with the formula. Derivative of e power x is e power x. Integrating e power x is e power x. Formula number 5. Differentiating a constant power x is the constant b power x ln b. Whereas to integrate b power x, a constant power x, the formula is b power x over ln b. So note the difference between this formula, this term, number 2, x power a constant, and the term number 5, constant power with the x. Okay, two different functions. Okay, this is x power r. Okay, this is like an exponent 2 power x. And then derivative of the ln x given to us, ln x is 1 on x. We get it from the ln u. Okay, but what is the integral of ln x here? We will cover it later. Okay, and number 7 under the derivative is log x base b is 1 over x ln b. Okay, if you are playing with the composite function, you need to multiply by the chain rule, using a chain rule, differentiating further the u. So there I'm collecting the important formulas, okay, beside the formulas of the trigonometry. Okay, let's go into this question. Okay, how to integrate sine 7x dx. And if you are to compare to the formula given to us, sine 7x, so given to us the formula for integrating sine x only. Okay, it's not 7x. So for that, we have to use the method of the U-substitution. Okay. Okay, so how to do that? Okay, first you must mention the u. Okay, by saying let u be the one that you choose. Normally, the inside function is the appropriate u, okay, to substitute. So u, and then in order to replace the x with the u, you are to differentiate. As you differentiate du on dx, we get 7, and then rearrange the x, we bring to the other side. So hence, dx is actually du over 7. So then you have to substitute everything in terms of a u. You cannot jumble up with two variables to integrate. So we substitute, okay, du on 7, we put it outside. And only if you have your term as one variable u, then only you can integrate. So, and then we can refer to the formula. The variable is a single, the variable is u. Sine x, sine u, dx, du is negative cosine single term variable. Okay, so that negative 1 on 7, we put it outside. So negative cosine u for the answer. After you have integrate, you have to replace back the u is 7 and x. So that will be your final answer. Okay. Next, let's look at b. So this is easy. Again, you cannot read integral of this function from the given formula list. You have to simplifying it by mentioning let u. In this case, we choose u to be 2 minus pi x and then differentiate the u with respect to x. Du dx is negative pi, and then rearrange du is negative pi on dx. We need to replace dx is du on pi. Okay, rearranging it and then change. Here pi is a constant value, we put the constant outside. So this cosine will eventually become cosine u, and we find the cosine u with respect to du by looking at our formula list there. Cosine x dx, single term x. Then you have to read it as sine, but the variable, the single u, okay, it has to be single u, and then after that you replace that. Okay, now what about c? Which one should be our appropriate u? So again, yeah, the clue is to look at the function at the most inside. Okay, the most inside function. So the appropriate u will be the 2x cubed. Okay, then we differentiate du dx is 6x squared dx, and then rearranging it, we need to replace the x squared dx. X squared dx is du over 6. So hence 1 on 6, put it outside. X squared dx just now yeah, is du over 6 and cosecant square u. So cosecant, where to get that cosecant with a simple term variable x? In this case, the answer is negative cotangent x plus c, but our variable is a single term u. After you have got that, you need to replace this u back into your x. So that is our answer for our finalized answer that you have to put down. Okay. Don't leave your answer in terms of your assigned variable u. Okay. Okay, so let us try these questions, okay, together. And beside that, I put down the formula list for our reference. Okay, are we ready? Okay, check my work. So for A, what is our appropriate u? We cannot straight away integrate. Given to us a single term, for example, cosine x, the x being sine x. So we have to choose or simplifying it by letting a single variable term u. For example, here as pi over 5x. Okay. So in order to replace dx later on, we need to differentiate. So this is where you have to be able to differentiate well. Okay. And what is dx? So as we replace dx, rearranging it, so dx is actually 5 over pi du. So let's substitute. Okay. Change everything in terms of the u. So help me, cosine u, and dx just now is 5 over pi du. Before you consider to integrate, it's good that you put aside or put in front the constant. Okay, cosine u du, and then we integrate. So the constant, put it back. The integral of a cosine u, we need to refer to the formula, okay, which is in this case sine u. And yes, because we are doing an indefinite integral, we need to put c for our final answer. Okay, so do we get the same answer? And yeah, we forgot the u. We cannot just remain the answer as a u. You have to replace the u as the variable that is given in the question. Our variable u is pi x on 5. That is our final answer, inshallah. Okay. Okay, question B. Cosecant square 3x dx. You can also write it as cosecant. Let's remain it as cosecant. So the inner function is 3x. Okay, let's get that as, and let's read that as u. And to replace dx there, we need to differentiate. Check my work. And what is dx? Dx is actually du over 3. Let's substitute all. So the question now will become cosecant square u, right? And dx is actually du over 3. The 3, you can put it in front for the constant, and you are to integrate cosecant square a single function u du. We refer to the formula list. Cosecant square x dx is negative cotangent x plus c. So as we integrate, this will become 1 on 3, put it, what was it? Negative cotangent u, okay, plus c. Don't stop there. Make sure you replace back your u as the functions of the given x. So what was our u? Our u is 3x. Let's see. Easy, right? Okay. So as of now, you should see that, okay, I'm preparing the template. You have to recognize or simplify the question by setting it as a simple u, and then substitute everything as u, integrate, and last to replace back into the variable given to us. Okay, let's check C. Okay, let's read together. Okay, check my work here. So what is the appropriate u? Okay, if you are choosing u as 3 theta, it will be complicated. And again, the appropriate u is the innermost function. Okay, so in this case, it's good that you replace the u as 1 minus 3 theta. Okay, so 1 minus 3 theta. Okay, so there's a tangent there, sorry. So we do need to know how to differentiate. So here, this is a formula. Okay, a tangent, we're differentiating tangent. Tangent is secant square x. Okay, so let's quote the answer. Tangent is secant square, but our x is 3 theta. And yeah, last time we learned about the chain rule. You need to further differentiate the inner function, this composite function, with respect to theta. Differentiating 3 theta with respect to theta, we get 3. Or another word, 3 secant square. So we need to substitute, this question, I believe this is d theta. So we need to substitute d theta. So where to get d theta? Or in this case, we have secant square 3 theta d theta. This is d theta. So meaning, let's rearranging it, meaning du over 3 is the secant square 3 theta d theta. So this is our du over 3. Okay, so hence then let's substitute everything. Okay, so we have d this thing is du. Let's put the 1/3 in front. So we have 1 over, this is the u just now, u being radical, and du. Okay. And before we are to integrate, it's good that you read it as a power form, okay, and use a formula. So this is u power -½ du. Okay, we need to integrate this using the formula of x power r. Integrating x power r is x power r plus 1 over r plus 1. Okay, so integrate the function above, 1/3. So we drop the symbol. So it is u -½ plus 1, so which is half over 1/2. Don't leave your answer like this. Why don't you flip it straight away? Okay, so 1/2. I'm flipping. Okay, plus here, and then replace, okay, the u there with the term. And check my work. I missed the negative over there, so be careful. So there is a negative there, okay, that we missed. So that should be it. Let's replace it. So it will carry 2/3. The u, what was the u? The u is the power half, or the radical of 1 minus tangent with an angle of 3 theta and plus c. Okay, that should be correct, inshallah. So this is fun, right? Okay, so how do we integrate this? This is power 9, so we simplifying it by setting the inner function to become a simple u. Right, so let's say that this is this. Check my work. And we need to differentiate, right? With respect to x this time around for the variable. Differentiating 3 is 0. Differentiating sine the 2, we put it back. Differentiating sine is cosine positive. And we need to substitute this cosine x dx in terms of a u. Okay, so the 2, let's put it, rearranging it so that I have cosine x dx. Cosine x dx being du. So we substitute. So the question now will become u power 9, and cosine x dx is du over 2. Okay, before we integrate, let's consider to put the constant in front. Okay, now we can integrate. Make sure that you only have like one term before you are to integrate. Okay, so half using a formula of integral x power r plus 1 over r plus 1. So here we have u power 9 plus 1 is 10 on 10. And plus c, don't leave your answer like this. Make sure that you replace. Check my work. So we have, okay, 1/20, 3 plus 2 sine x power 10 plus c, okay, for our final answer. Okay. Okay, next, why don't you pause this video and try question E. Okay, let me give you 3 minutes, everybody. Try question E, and choosing the correct u. This u should be this function, and we'll compare answer. Okay, try out the question. I'll give you 3 minutes. So we compare answer. Okay, how was it? So it's not that straightforward, right? To replace the du in terms of a u. So here we need to adjust, okay, like this one. When differentiating, okay, because we need to replace this x minus x dx. So after we differentiate, I introduce negative. as we introduce negative, this is so that we will read it as 8 minus x. Okay, so when you are introducing there, meaning you are factoring negative over there, make sure that you expand and get back your initial function. Okay, so there we rearrange such that the 8 minus x dx, the one that we are to replace, okay, 8 minus x dx is the du over negative 2. And then rearrange first before you integrate, and then integrating sine x, single term x is negative cosine x. Okay, and our case is our single term u, so it's a negative cosine u. And don't forget to replace back in terms of your x, and don't forget the c. When you are reading the c, put it at the last end. Okay, so that should be the answer for E. So that's it from me. Okay, thank you.